All right, welcome back, class. Um, in this lesson, what we want to take a look at is esters, particularly esterification. Um, so, esterification is this process where we're condensing some certain types of compounds together. So, we've learned in a previous lesson that esters are formed in lipid-like compounds, like your like phospholipids, triglycerides. The ester link is what actually is holding together the two parts of what we call an ester compound. And those two parts is essentially we have an alcohol plus some sort of organic acid. Okay, so that's always going to be the case here. And then, of course, there's going to be a reaction, and then organic acid is going to mix with that alcohol, and we will get some sort of ester compound. And we'll learn in lab that basically this reaction is reversible. So we can use this equilibrium double arrow because it does go back and forth based on some input that we have. So we'll find that there'll be things like acids that we'll add, and by adding in another acid, an inorganic acid, we basically add hydrogen ions to this, and we'll also end up adding some heat to our reactions, and that will catalyze the combination of these two things to work a little bit faster under those heated conditions with extra protons, and we'll get these ester compounds. And then when those conditions change, when it cools down, then the reaction will actually go back, and you'll get these breaking apart. You'll get this breaking apart again back into its monomer units. So let's take a look. Let's start with the first example I have for you. The first example I have is, let's think of some propanol. Okay, and so from the first part of this, we see OL. We know that that means the OL ending lets us know it's an alcohol. And the propan part, we can tell that that's a single carbon, an alkane, and that lets us know there's 3 carbons in that. Let's take propanol, and let's use ethanoic acid. And we all know from our studies in class, ethanoic acid is also referred to as, more commonly referred to as acetic acid. Okay, acetic acid. So we want to figure out what the ester compound is. Well, let's go ahead and put this together. So we know propanol is 1, 2, 3 carbons for like propane, right? So we got 3 carbons. And there's an alcohol group on one of those. There's a hydroxyl group, right, on one of those carbons. We'll just put it on the first carbon on the end. Why not? This one right here, we could have it right here. 2-propanol, isopropyl alcohol. We could put it there, and the reaction. We could get a reaction with that one, but we're just going to put it here on the end. We're going to call this the primary carbon. We're going to call this carbon 1. So there's propanol. And then acetic acid, right now we'll call it ethanoic acid. We know that propane or methane, ethane. So we know from that right there, that's 2 carbons. 1, 2 carbons. And so for it to be an acid, we know that our organic acids, that there is a carboxylic acid group that is attached to a part of that molecule. And we've been discussing that with our mechanisms, that right there, what we're going to end up getting is some water that comes out. So right here, we're going to get water that comes out of the system. And when that happens, what we have essentially is all this right here. We can think of all this as the R group, right? So if we just thought of just that right there, right? Just the OH, and all of this, it doesn't matter what it is, but it's just the rest of the molecule. It's the R. And And what we've done is we've taken this part right here, which we know is the, oops, that was pretty, not a good looking C. That's a little better. Took the hydroxyl group, right? And right here there's only one carbon on this, but there could be a whole lot more. This could be a completely different acid. It wouldn't matter. That's just the rest of the molecule. So again, what we're doing is we're just looking at the mechanism. What's going to be reacting? Okay, what is actually going to be reacting? So what we did was we showed right there that some water is going to come out of this. And so the rest of the molecule, all we have to do is recopy it. And we're just worried about the fact that right now, that once this is gone, this oxygen right here and this carbon right here, they're going to bond. They're going to bond. And we can see that if they come closer together, right now, this double bonded oxygen to this carbon, if we were to take this whole molecule, move it over, we can see that the angle at which this is going to have to change. As it gets closer, there's going to be some repelling forces that are going to cause this right here to sort of swing out more this way and straight as this gets closer to this side of this molecule. So we've got 3 carbons. 1, 2, 3 carbons. This carbon is bonded to that oxygen, right? And then we can see that this oxygen now has to be bonded to this carbon. And we said that that double bonded oxygen is going to swing up, and then there's one more carbon there. So what we're going to do is just focus on getting the backbone of this thing put together. And then once you have that, draw in the bonds where you know the rest of your hydrogens are going to have to be. That way it's a little less busy when you're first doing this. And once you get used to it, then you can easily go in and make those adjustments. Let me get this out of the way, just so we have enough room to do all this. So right here, let's think about this. So we have propanol, we have ethanoic acid. So the question is what's the name of this thing right here? Well, the way we name this is we right here we know that our ester linkage is right there, right? So what we want to do is we want to name this according to the alcohol name first and then the acid name. Well, right here, if we were to look at this, so connected to this branch right here, it kind of looks like an alkyl group that's three carbons in length. So we could call that propyl, right? 3 carbon alkyl sort of branch. It's a propyl. We've learned that in previous lessons. And then right here we have these 2 carbons. So this is ethanoic acid. So when you name these things, right? So when you name these things, let's see, ethanoic acid, what you do is you drop this part and this part, and you exchange it with 8. So what we would do is we would call this, we would use the root part of this, which is right there. We could call this propyl ethano. And then right there we said we were just going to add in that extension. So we could call this propyl ethanoate. Okay, that's not too bad. It's pretty easy. Handwriting's not too attractive, but that'll work. Let's look at a line structure. Let's see what this mechanism would look like a little more the organic way. So we have 1, 2, 3 carbons right here, right? All right, so if we go 1, 2, 3, correct? Then we see we have a hydroxyl group attached. 1, 2, 3 carbons. And we have 1, 2 carbons right here, correct? So we've got 1, 2 carbons, and on this one we have the hydroxyl or the carboxylic acid group, right? There's 1, 2 carbons, 1, 2 carbons. And we can see right there, there's where the reaction occurred, right? Oops. That's a pretty horrible arrow. All right, that's a little bit better. And let me get this out of the way for us. All right. So once that part right there reacts, it's just a matter of sort of combining everything else. So we know we're going to have an oxygen that's going to be bonding between this and and here, because we know, remember, we know that right there, that's coming out. All right, that right there is coming out. There's going to be water coming out of the system right there. So we're going to have that oxygen right there, right? And we know that it's going to bond to two sides. That oxygen right there is going to end up bonding to a carbon, and it's going to bond to that carbon right there. So we know that there's our 1, 2 carbons, 1, 2 carbons from the acid side of the molecule, right? And then we have over here, see where this oxygen is? There's carbon here, that carbon here, this carbon, this carbon, this carbon, and this carbon. So we need 3 carbons. So this oxygen goes to 1, 2, 3. Okay. So this represents this. You can see there's 1, 2, 3 carbons. There's 1, 2, 3 carbons. So here's our propyl ethanoate. We also could call this propyl acetate. So we can go back to the naming rule where we have the whole 8-ic combination. So like in previous chemistry lessons when we were naming inorganic acids, we would have the 8-ic 8-us rule. Well, here we see we've got acetic acid, so we can kind of go in reverse. That IC can be removed, and we can go back and replace that IC with ATE. So we can remove this IC and replace it with ATE. So we can call this propyl acetate. So either propyl acetate or propyl ethanoate. So if we were to use ethanoic acid as the name for our acid, we would use this naming system. If we were using acetic acid, we would end up naming it this. It's just a matter of being consistent with the naming system. Okay, so let's try another one. I've got a couple here that I thought we could look at. All right. So let's see number. The second one. Let's do something. Let's do something a little bit different. Let's try something called excuse me. Let's try let's try some benzyl alcohol, and let's go with, I don't know, something a little weird. So how about octanoic acid? Just so we have some more carbons. All right, so let's figure out what we would have over here. So benzyl alcohol. Well, we can tell from that we have a benzene ring that we're going to have to be using. Well, that's not a. That started off okay, but that's really not a. Oh, that's even worse. Let's try this again. Okay, that'll work. So remember our benzene ring has alternating double bonds that are in a cyclical form. All right. So if we were to come over here and put a carbon and then a hydroxyl group, we basically have benzyl alcohol. Okay, and now we're going to mix this with octanoic acid. Well, we've got 8 carbons, right? So we've got to have if we've got to have 1, 2, 3, 4, 5, 6, 7, 8, right? So we want our carboxylic acid group, let's just put it on this side. So if we do that, let's reverse how we do our up and down motion with this. I'm going to start at the top this time. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. The reason I'm going to do that is because I want to be able to do this to properly show my carboxylic acid on this side. There's still 1, 2, 3, 4, 5, 6, 7, 8 right there, right? Right, 8 carbons there. So our mechanism we know is happening right there. All right. So now what that means is all of this sort of links together. So we need our benzene ring. Okay. We have a double bond here, alternating double bonds throughout that cyclical molecule right here, and then this is going to go down to this oxygen right here. This oxygen is now chemically bound to that carbon, and then we've got to go from this carbon to 1, 2, 3, 4, 5, 6, 7 more carbons. So that would be 1, 2, 3, 4, 5, 6, 7, right? Not pretty, but it's for training purposes this will work. So we still have, see, on this side there's still 1, 2, 3, 4, 5, 6, 7, 8 carbons all together. Very good. So it looks like we've got this together. So there's our benzyl alcohol, there's our octanoic acid. All right. So let's see, let's erase this. Let's get this named. All right, so octanoic acid. So if we remember up here, right, we had ethanoic acid. We had dropped the IC and we added the O, or we added the ATE. So let's just come over here. Let's drop the IC on this, and this we would call it benzyl octanoate, and that would be the name of our ester. All right. If you're, and I always forget this. I'm just remembering. Water came out, so for a balanced chemical reaction, of course, we would have to write our plus H2O. I always forget this. I don't know why. My students will remind me of this. This is just one of those things I forget. I know it's missing. I mean, I know it comes out of the system over here. I just always seem to forget to write it over there. But don't forget to write it. You have to write a balanced chemical equation. So another name for octanoic acid, this is a less common name. We would not use this in class, but since we're talking about naming systems, I want to kind of use this for some training. So caprylic acid, all right? I would never call it that, but and it has actually many names. But this right here will follow that 8-ig Rus rule, right? So we could also call this product here benzyl, and then we would drop the IC, right? And then we could add, so the 8-ic, and then we could add the ATE and call it benzyl caprylate. One of those would work. So, hopefully that helps. It's a little bit of what we're doing with our mechanisms, and we know these are our condensation mechanism, right? So we could come back up here and look at this, and we realize that there would be some hydrogen ions here. We would probably also add some heat to this, and we do know that eventually what happens is this reaction, it will go backwards. It will come out reaction when everything changes, and we'll get this equilibrium where it goes back and forth depending on the conditions. All right, so hopefully that helps a little bit. If you have any questions, feel free to contact me. Take care.